everyone. Today we are going to start with a topic which you might be very much familiar with, which is diffusion. I hope many of you are very much familiar with the term diffusion. Like you might have come across the few facts around us which are taking place due to this phenomena. Like if you open a bottle of a perfume or if you spray a little perfume into the room, you will feel a scent spreading around quickly, and after a few seconds you can feel the scent all around the room with the same intensity. Similarly, at times your mother might be cooking some curry in the kitchen and you can feel the aroma of the curry all around in all rooms of your home, actually, if you are keeping the door open, because the particles of the fragrance or the particles in the fragrance, they are spreading quickly due to the diffusion, which is a phenomena. So if we want to arrive up to some definition of diffusion, would it be some reasonable explanation to this would be that it is the movement of particles from the region of high concentration to the region of low concentration. Actually, particles tend to move from their from the area where they are higher in concentration to the area where they are lower in concentration. But the main aim of the particles to do this is to spread out evenly. Okay? So this is to fill up any available space and to spread out evenly. That is the main aim of diffusion. So we can define diffusion as the process by which particles move freely from the area of high concentration to the area of low concentration to fill up any available space. Now let's see how diffusion takes place. For this I have I'm showing you the air and bromine demonstration, in which we have two gas jars, one filled with the air and another with the bromine. Air is colorless and the bromine is reddish brown in color. I am actually going to remove this lid which is placed in between the two jars. When I remove this, something like this has happened actually. If you check this, what has happened actually, that the particles start diffusing from their higher concentration, the air particles from their higher concentration to lower concentration, and bromine particles from their higher concentration to lower concentration. And as a result, after a certain period of time, you will see that both jars look alike. Definitely the dominating color is a reddish brown, so both jars will be the same color, that is a reddish brown color. That is air mixed with bromine due to diffusion. Why does this diffusion occur? That is important. Both air and bromine made up of tiny particles, and these particles, because both are in gaseous phase, they are moving at random. In fact, matter, all types of matter move at random, but gaseous particles are highly energetic, they move much more randomly. Okay, the bromine particles diffuse into the spaces between air particles, and air particles diffuse into the spaces between bromine particles. When both the jars look alike, it means these both have evenly spread it, and we see that homogeneous mixture is obtained. So the basic idea why diffusion occur is particles move at random, which is the main postulate of kinetic particle theory. Now moving on to diffusion in liquids, I'm going to demonstrate it with one very good practical, that is sprinkling few crystals of potassium magnate, which is a very intense purple color solid, into water. It actually dissolves in the water on itself, but because it is solid and water is a liquid, so the rate of diffusion of a solid is little slower than that of liquid, and the rate of diffusion of a liquid is little slower than that of gases. So what will happen, that this deep purple solution will first stay at the bottom, and gradually you will see a very much uniform purple solution after many hours. It cannot take place as randomly as you have seen in the case of a bromine and air. Bromine and air both are gases. Over here this is a diffusion in a liquid, and that is diffusion of a solid in a liquid. So this is a little bit slower. Let's see what are the factors which can enhance the rate of diffusion or which can lower the rate of diffusion. Number one is the temperature. Temperature is basically the measure of the kinetic energy of the particles. As you know, more the kinetic energy of the particles, faster it will move. So diffusion is something which is directly related to the rate of diffusion. That is, more the temperature, more the rate of diffusion, because kinetic energy of the particles increases and they move more randomly, and so in other words they diffuse more randomly. And moving on to the next factor, which is very much influential in the case of the rate of diffusion, is a mass. Mass is basically the more massive is the substance, so the rate of the diffusion. Like you might have seen, fat people actually can't run fast. So that is basically, I'm just explaining it with the example, but actually the more massive is the substance, lower is the rate of diffusion. So let's see effect of temperature on the rate of diffusion in the case of the same demonstration which I just shown you, that is of adding potassium magnate crystals into water. Now what would you observe if it is a boiling water? You would see the solution will become uniform purple in a much shorter time rate, that when water has been boiled, the temperature of the water has increased, and so the rate of diffusion increases. Now, effect of mass on the rate of diffusion. Mass is something which in chemistry, when we are talking about, one in a everyday life we are talking about grams and kilograms, but when in a chemistry we are talking about the mass of the particles, and specifically we are much more focusing on the gases. So the particles mass is particles actually exist in two forms, either these are atoms or molecules. If it is a mass of an atom, we say relative atomic mass. If it is a mass of a molecule, we say relative molecular mass. Smaller the relative molecular or atomic mass, lighter the gas is and the faster it moves. The table here shows the calculation of the masses of some gases. You can check this out. I am going to explain you how we have calculated the masses. Hydrogen is with the formula H2. If you check in this, H is the atom, which from the periodic table, if you consult, the relative atomic mass of hydrogen is 1. And because there are 2 atoms of a hydrogen, so we multiply this 1 into 2, and that the relative molecular mass is 2. Similarly, the calculation of the mass of oxygen is 16 relative atomic mass of oxygen into 2 times, because there are 2 oxygen atoms. So the relative atomic molecular mass of oxygen is 32. For carbon dioxide, the formula is CO2. That says carbon is 1 and oxygen are 2. So the relative atomic mass of a carbon is 12 plus relative atomic mass of oxygen is 16, which is because there are 2 over here, so multiplied by 2 and you get 44. This is how you calculate relative atomic mass, relative molecular masses. Atomic masses are always given in the periodic table for the specific element. We have picked atomic masses, like I have picked atomic mass 1 from the periodic table for hydrogen, but because there are 2 atoms, so I multiplied it with the 2, and so the relative molecular mass is 2. Now, given the relative rate of the diffusion of the gases, like for ammonia, if I need to go for the relative rate of the diffusion of the gases, for ammonia I'll calculate its MR. Like for nitrogen, the AR is 14, 1 into 3 for hydrogen, and you get MR 17. For sulfur dioxide, the MR calculation will be 64. For HCl, you will get the relative molecular mass 36.5, and so the comparative rate of diffusion depends on the mass. So the fastest rate of diffusion is of ammonia, then of HCl, and then sulfur dioxide. Moving on, how do you show rate of diffusion is affected by MR? We do so using the setup shown below, in which there is a long glass tube with 2 cotton plugs. In this cotton plug, we have soaked this cotton wool into the concentrated ammonia solution, so the gas which is actually going to escape from this corner is ammonia gas. And on this side we have concentrated hydrochloric acid, so the gas which is escaping from this corner is HCl. Wherever these 2 gases meet, there will be a white ring produced. This is of ammonium chloride. This ring is produced closer to HCl land, and what is the reasoning for that? That is because ammonia relative molecular mass is 17 and that of hydrogen is 36.5. Because ammonia is lighter in weight as compared to HCl, so ammonia travels faster. Hence ammonium chloride is formed further away from ammonia because it has traveled more distance, and it has formed closer to HCl. This is the equation showing up the formation of ammonium chloride. This is ammonia joining up with HCl and changing into the white ring in the center of the tube, NH4Cl. Now, This was a demonstration. If you quickly look into that, both gases diffuses, the white ring was formed, white fumes of ammonium chloride over here, the cotton wool and the position of the ring and everything is very much clear. Now comparative rate of the diffusion of the gases. If you again, I'll explain this again with the help of one very beautiful demonstration that we have two gas jars. You can see one gas jar is this outer jar and one is this gas jar. In the inner gas jar there is air. In between the inner gas jar and the outer gas jar there is a semi-permeable membrane. Can you check? There is a semi-permeable membrane over here between this jar, which is filled with the air, and the outer jar, which is filled with the hydrogen. And this inner jar is then connected with this U-shaped tube. In this U-shaped tube water is filled, and we have labeled the water level in the tube at the start of experiment as X. Okay, we let this experiment to take place and we will note down any change in this level of water. Now, what will happen to the level of water? For this you need to understand one thing, the comparative rate of diffusion. Comparative rate of diffusion, for that you have to keep one note in your mind that amount of the gas, if it is less than 31, we would say that it is lighter than air, and if it is more than 31, we would say it is heavier than air. For hydrogen, the MR we just calculated in the previous discussion, it's 2. And for air, because we are assuming that air is 31, so air is heavier over here. The rate of diffusion of air out of the jar is less, but the rate of diffusion of hydrogen into the inner jar is more. So after a certain period of a time, there will be more particles of hydrogen gas in the inner jar. As a result, because these are particles of matter and they will definitely occupy some space, so more particles in the inner jar will exert pressure on the water column and the water column will fall. That is basically hydrogen diffuses more in the inner jar as compared to the diffusion of air in the outer cylinder. So more number of molecules in inner gas jar will exert pressure on the water at X and it falls. That is a very beautiful demonstration with the help of which we can understand the comparative rate of diffusion of the gases. This was the